Hi everybody, it's July 12th, 2016, and it's been a couple months since I acquired this freebie generator, and I decided to get back to work on it today, just so I can hopefully wrap up a project and have it actually on the done list, as opposed to all the other projects that I have ongoing that are still not finished. So last time I was talking about this generator, I was talking about that this is a Gen Pro 9,000 watt generator, and I didn't really know much at all about this generator. At that time, it's got a Vanguard Briggs & Stratton 16 horsepower V-twin on it. And what I ended up discovering is that this generator is actually manufactured by a company called Gillette Generator Manufacturing. Don't know much about the company, but what I do know of the company I like, because they have a website, and on that website, under the support section, there is a downloadable PDF file, owner's manuals, and more importantly, a service manual. And the service manual has plain spoken descriptions of diagnostic procedures for this machine. Obviously the company knows that not everybody wants to have to be at the mercy of a generator service person. Not that there's anything wrong with generator service people. Of course, if you see part one of this series, you'll see that the particular person that was hired to work on this generator kind of dropped the ball, but that's another story. Anyways, what I had discovered in part one was that the capacitor was missing, and I went on, got that PDF file, looked at the file, and it says right in the documentation that almost all of their generators use the same size capacitor, which is a 50 microfarad 440 volt AC capacitor. Well, as luck would have it, I happen to have, and I've had right along and didn't even realize it, but in my bag of tricks, I have a good used 50 microfarad capacitor that's pulled out of a motor that I scrapped. So this is a run capacitor, more than likely, for a large 220 volt motor. Now, this is only rated for 370 volts. So ideally, I would want the 440 volts. That being said, during normal running, this unit is going to develop a max of 230, 240 volts. But I suspect that the reason why they're putting a 440 volt is to help with any surge that might occur. So this 50 microfarad 370 volt might not last as long as a 50 mic 440 volt would, but it should last long enough for me to test and make sure that this is a good working generator and all the other functions of the generator are okay. If I get everything else sorted away, what I can do is leave this in there for the time being and order a 50 microfarad 440 volt off of the internet, which is the cheapest place to buy them, and just keep it as a spare. So as far as replacement of the capacitor goes, this one's already been removed. The wires that were left behind have no terminals on them whatsoever, which I'm not surprised to see, because they expected these wires to be actually wrapped around the terminals and soldered. And I suspect the reason behind that is because there's so much vibration going on here, they didn't want to rely on a spade connector. So this capacitor, because it came out of a motor, did not have the wires soldered to it. It has 0.250 inch or quarter-inch lugs that spade connectors, push-on connectors, would push onto. But because we don't want to have the possibility of that loosening up, what we're going to do is we're going to utilize these little holes on here, and I'm going to push the wire through, bend the wire over, and solder it. So that's what I got to do next. The problem is these holes are actually a little too small because they weren't designed for that. So first thing I got to do is drill out these holes larger. So hopefully I can drill through these thin lugs without damaging this thing. The problem with drilling through something like this is as soon as the drill breaks through, it tends to grab, and it's very easily, could just twist and break this right off, so I'm going to go slow. Getting close. There we go, there's one. There's two. Alright. Alright, so I just passed one of the wires through, and pass this wire through on this side, and then I'm just gonna bend that wire back over behind the lug up like that, and now when I flow the solder in there, that should create a good mechanical and electrical connection. I think what I'll do, because this one's shorter, I think what I'll do is I'll get this one done first. I'm going to flow that solder right into that braid, and then flow the pool of solder right down to the lug. Once again, I goofed and didn't hit the record button on the camera, so you missed me soldering this on, but basically what I did was I just flowed solder right into the braid of the wire and onto the lug itself. Use my Weller soldering gun, get plenty of heat in there. So now I've got a good secure mechanical and electrical connection. And now I'm going to slide this protective boot on, which the original capacitor was probably a metal can one, and probably didn't have this big lip on it like this does. So that's making getting this on here a little bit trickier, but I'm sure I'll manage. There we go. Not sure what the purpose of this boot is. I guess it could keep moisture off of there somewhat. And the other big thing it does is it keeps all of the goo from leaking on out of this capacitor when it gives up the ghost, which often happens. Alright, so now I gotta go find a screw and a nut to fit this and secure this in there. There were 4 screws holding this outer cover on, and not one of them matches. 4 odd screws. So go figure. The case actually has little threaded pieces welded onto it to act as nuts to give the screw something to screw into for the cover, but this just goes through the sheet metal. So there must have been a nut on the back side, so I'm gonna have to, I think maybe I'll find 4 screws that match for the cover so I can restore that back to some semblance of order. That's all I know. It's a little anal retentive, but it's also kind of a pain when you go to take something apart and you gotta reach for a Phillips head, a regular screwdriver, and well, this is getting regular, but you know what I'm saying. Okay. Several minutes of weeding through my little drawers of hardware and boxes of miscellaneous hardware, and I found 4 screws that look like they're a good match. And I think they're the right size. That they are, okay. What I like about these is I notice they've got that serrated lip there, so they should be fairly self-locking. On the subject of self-locking, ideally I probably would want a self-locking nut in this application on the back side, because again, this is high vibration they're dealing with here, which is, I don't know what was on here for an original fastener, but I wouldn't be surprised at all if there was originally a self-locking nut on here. That's secure. I'll take one more peek on the back here, make sure I don't see any wires that are off. Everything looks good. You can see here on the back of this switch where they've got these spade lugs, 1/4-inch spade lugs, and what they did was they actually passed the wire through the lug, the hole in the lug, and soldered it. Again, they didn't want to have the thing running and vibration to cause the wires to pop off and be smacking each other around in there and shorting things out. That is a tight fit underneath there. This lip goes. Not crazy about that design. This lower lip needs to go in here. Now the irony is, if I loosen these two bolts, then I can make that happen pretty easily. But then once I loosen the bolts, and I put the cover on, then I won't be able to put a wrench on the inside here and tighten this. So that's kind of funky. Let's see if I can't just bend this lip a little bit. Oh, okay, I got it. There we go. Yeah, let's try this thing out. Alright, let's see. I'm not sure if the battery is still going to be charged on this thing. It's been sitting a couple months unused. Let's see if I remember how to start this thing. Key switch is right here, but I'm looking for a choke. I don't remember if there was a manual choke on this thing or not. Oh yeah, here it is. Pull out the start, push in the run. Alright, so it's out. So I gotta make sure the gas is on. We get a fuel pump. We get a shut off right here. Oh yeah, and I think, as I recall, I think the guys are saying there was 2 fuel shutoffs on this, maybe. Maybe not. That was just running off of what was in the carburetor. I was just about to say, I don't see any fuel in this fuel. In this fuel filter, it's got a clear fuel filter. I think I had the fuel off. I think it was on this whole time and I ended up turning it off. Yeah, there we go. Looks like the fuel's going in there now. Alright, so it runs the electric drill, but when I put the air compressor on there and fire it up, I can hear the motor surging in speed, which means the voltage is way too low to run that thing. So I better go get a voltmeter and see what's coming out of this thing. Well, I just realized that this is a 15 amp circuit here. This is a 20 amp circuit here. The way I could tell, this is a GFI, that's why it's got the test and reset button. But in addition to that, it's only got vertical slots on the outlet, so that's a 15 amp outlet. It shouldn't make a difference because it's being powered by the same, I would think. But I'm wondering, this switch right here, it says 120, but over here it says 120/240. Full power output on bold voltage selection. So maybe I need to run it off of this. And I also wonder whether or not this switch needs to be switched. Let me try that test again. No load. That's with the compressor on. I actually don't think the compressor was surging after all. I think that was just the normal oscillating noise of the motor, and it was just kind of blending in with the noise of this generator, and sounded kind of weird to me. But I mean, if the voltage was dropping way down when I put the compressor on, then I would be concerned. But 160, holding at 116 plus volts with the compressor on tells me that it's working the way it should. So I think we're going to call this a fix. What? Actually completing a project? Alright, so like I said, maybe at some point down the road I'll snag a deal on a full 440 volt AC rated capacitor to keep as a spare. Otherwise, I'm pretty satisfied with the way it's running. That is a nice, easy fix and a really nice score for a free generator.